Hi there, today we're taking a look at the Amstrad CPC464, and of course this was a computer from 84-85, so it's the next generation after the Sinclair ZX Spectrum and 2 generations after the Sinclair ZX81. So what you could expect from this computer was better graphics, better keyboard, better sound, better expansion capabilities, and basically that's what you got. And yeah, I remember I really wanted one when I was younger, but I couldn't afford it. So I had a Sinclair Spectrum from 1982 to 1987, and I skipped straight to the Atari ST. But I really wanted this computer as a kid, simply because the graphics were so much better. As far as I know, you could change the color of every single pixel. And I remember in your computer magazine, there was a program that could do fractals, and whoa, it just blew my mind, and I just wanted this machine so badly. But anyway, I have one now, so let's just run the Hello World program and see how that runs. The Amstrad, of course, came with a complete set with monitor and a built-in cassette. So you just had to buy the computer and that's it, nothing else. And because of Alan Sugar, he made sure that the price was really competitive. So you could basically buy an Amstrad including the cassette storage and a color monitor for the same price as what other vendors were selling just the computer alone. So yeah, it was a really good value. So let's just type in the Hello World. And as you can hear, the keyboard is a real mechanical keyboard, and it's really nice to type on. So anyway, let's just run the program here, and it prints Hello World. The machine has a Z80 CPU and it's not the fastest in the world. But yeah, it still works. Of course, with better screen graphics. It also uses more memory for the screen. And to type something on the screen or to write something on the screen would take more CPU power, simply because you need to fill in more memory. Okay, so let's run it again. And you can see it takes quite a while to fill out the screen with text. So yeah, let's switch on the light in the room again and let's take it apart. If we look at the machine from the outside, of course it has it's very long. It has a really nice keyboard, including a numeric one. And although you cannot use this for business, I think that is quite a neat feature. Then on the right it has a cassette player with a cassette counter. If we look at the back, we have a little loudspeaker here. We have a monitor output. We have 5V in, a floppy disk connector, a printer port, a joystick port, and audio output here for stereo speakers. And at the back here, at the end, we have, that is difficult to say, like that. At the end we have a power switch and a volume control. So as I said earlier, the monitor was a part of the system, and the power supply is actually in the monitor itself. And yeah, you could buy a TV modulator, and I think I have one somewhere, so that you could connect this machine to a normal TV. But the modulator was really expensive because it had to include the power supply. But okay, let's take it apart and see what we find. This one is serial number 10,096. So I don't know whether they started from 0 or they started from 10,000, but nevertheless it's quite an early version. Yes, we do, and we need to clear some off. Okay, like this, and it's kind of dusty inside, and I need to clean that up. So let me just do that first, and then I'll come back to you. Okay, so I got it apart, and we're looking into the top of the box now. And what we have basically is a keyboard here on the right and a cassette player over here. And two things are quite obvious. First of all, this is basically a standard cassette player. There's nothing real fancy about that, except that it has this special connector. And of course, by using a standard cassette mechanism, you would save a lot on tooling cost. Apart from that, the keyboard is on a single-sided PCB. The way it's inserted into the chassis is by snap-ins. And once you have snapped in everything, you would melt these two little dots here, and then it would stay. So really a cheap design, but it has proven quite sturdy. and as you can see, it's really nice to type on, and it works pretty well on even today. Okay, so here's the internals of the machine itself, and it's fairly straightforward. What we have is the CPU, the Z80A CPU, running at 4 MHz, and that is the main chip, of course. Then we have underneath here, under this heatsink, we have the Amstrad ULA or Amstrad ASIC. This, of course, is a custom IC, and it's basically doing address decoding and taking care of the memory chips, which are down here, and total 64 kilobyte. So if we compare it to slightly earlier machines, we see that we need only now 8 RAM chips to get 64 megabyte, and previously we had needed a lot more, typically 32. Next to the memory we have some logic chips, probably doing address decoding and some other glue logic. On the left we have an I/O chip, which is the very old 8255. This is a standard IC for I/O, and it has been used for donkey years. Under that there is the video controller chip, and this is a standard 6845. So there's nothing fancy about that at all. On the left we have the audio chip, which is also a standard chip. This is a General Instruments AY3 chip. Under the sound chip we have the basic ROM, and the interpreter for basic is in there, of course. Okay, on the analog and the I/O side we have the video out here, goes through a buffer, a 7400 buffer, and some resistors to get the levels correctly. Next to that we have the power input, and that goes through some fuse resistors here. And the power input must be 5 volts because I don't see any voltage regulator on the board here. Then we have here, this is a floppy interface, and then we have a printer interface up here. Interesting enough, there's no floppy drive controller chip on this board. So the floppy controller must be in the floppy drive itself. So what is on this connector must be general expansion, like address bus and data bus and whatever from the main CPU. So for a machine that has a built-in cassette tape, I think this is a good design choice. Leave the machine as cheap as possible and put the expensive floppy drive controller chip together with the floppy drive. So yeah, very nice design there. Okay, after that we have the printer port, and basically there are some resistors on the inputs, and the output are driven using this chip here. So nothing fancy on there. Then we have a joystick input, which is also driven by the 8255 I/O chip. This chip has 3 ports of 8-bit each, so 24-bit, and enough to drive the printer and the joystick here. Finally we have audio out, and that comes of course directly from this chip. And finally we have the keyboard connector on the left here. So the Amstrad machine again is a very interesting low cost design. You can see that they have spent time getting the price down. Very straightforward, and the ASIC is not too complicated. Keeping also the design time low. So apart from the software in ROM, this is basically the kind of machine you could design yourself. But of course, cost-wise, you couldn't compete. Let's just flip it over and see if there's a voltage regulator on the back, or see whether there's a loudspeaker or something like that on the back. And yeah, there isn't. This is very straightforward. Just a single PCB, and that's it. The only thing we haven't really looked at is the cassette tape itself, and it's basically a standard mechanism, and I'm not going to take that apart because it's full of little springs and mechanical stuff. So if we look at the main PCB, I think that is the only thing that is custom made by Amstrad for this cassette player. So apart from a power amplifier, which is soldered in here, it's a Japanese amplifier obviously, and a little loudspeaker, it has a relay here that can turn the motor on and off. So apart from that, it's basically a standard cassette interface. So yeah, that's it. Very straightforward little machine. Thank you for watching, and I'll see you again real soon.